Swayam Prabha. Digital India. Educated India.
Hello all, I am Niasha Jahagirdar. I have total 22 plus years of experience from the industry field. I have the experience from machine automation and IoT. So today we will be having session for IoT. As you can see on the screen, we will go through these topics. So definition and basic principles of IoT. Then we will see evolution and current trends in the IoT. Then some of the key components and technologies. Since I have industrial background, we will see the layers of architecture of IoT in the perspective of industry. Word is consist of OT and IT parts, so we will check both the parts, OT and the IT side of the IoT. So these are the things we will be going through. So we will start our session with the big term Industry 4.0. So this is the big umbrella. IoT is one of the segments out of this Industry 4.0. As you can see on the screen, this big umbrella has many segments like IoT. So it consists of blockchain, then it consists of cyber security, artificial intelligence, big data analysis, system integration and cloud computing. So this is the digitalization of the and revolution of the industry, and as we will move forward, we will see just a small segment out of Industry 4.0, which is Internet of Things. So when we say Internet of Things, it is basically interconnection of the things. So when we say thing, it's a device or any object around us. For example, we take the example of bottle, water bottle. So now we want to make that bottle as a smart bottle. So how can we make that? So we don't know the color of the bottle, we don't know the water level of the bottle, we don't know the temperature of that bottle or the content of that bottle. So what we can do? So we can connect the battery operated sensors to that bottle, which can sense the temperature of the bottle, maybe the pressure of the bottle, then the color of the bottle. So all these parameters which are related to that bottle, now we can measure, we can monitor those parameters. So the bottle along with that sensor becomes a smart bottle. So this becomes the thing for the IoT. So that is what the anything which is around us, the any object which is connected with any kind of a hardware or any kind of a sensor through which we can monitor the parameter, that becomes the smart thing, and that is available on the internet. So that can be connected through the internet. We can talk to that thing or that object through the internet, and that is what is the term called as Internet of Things. So now we will check the difference between IoT and IIoT. So IoT is Internet of Things or the interconnection of things, whereas IIoT stands for Industrial Interconnection or Industrial Internet of Things. When we apply this IoT term in the field of industry or in any plant, that becomes the IIoT. So how it differs? So IoT is commonly used for consumer usage, while IIoT is used for industrial purpose. In the consumable items, there are like oven, any kitchen appliances, any small lights or any things which are in the domestic environment. Whereas when machine are talking to machine or any devices or any plant, any energy sources, these all are related to industrial terms. So the IoT related to industrial terms become the IIoT. So this is the major difference between the IoT and IIoT. So in the next slide we will check. Okay, so this is what the IIoT I already have explained. Moving ahead, now we will see what is the evolution and which are the current trends in the IoT. So there are two major sectors in the IoT. One is pre-internet, and now this is the world of internet. So in the pre-internet, as you can see, human to human connection through the telephones or sending the SMS or using the pager. That was the media of the communication. Moving ahead, now since we are in the part of IoT or in the world of IoT, so internet of content, now everything is available on the www, right? We can send emails, we can share the information, we can have entertainment over the www things. Moving ahead, the next is internet of services. Now you got all kind of services, whether those services are related to product, whether those services are related to software, any industry, any home appliances, any domestic or industrial purpose are available on their website or their web portal. So this is the next evolution in the technology towards the IoT. Then internet of people, now we can connect to anybody in the globe at any point of a time, in a day or in a night, through Skype, through Facebook, through Instagram. We can have the information through YouTube. So now everything is available on the internet. So that is the next trend. So since this is the world of internet, we want to connect every object, every person, we want to make them available on the internet. So we want to basically connect industry to the upper level management, all the kitchen appliances, home appliances, all the plants, all the shop floors to the management, to make everything visualize for their better understanding. So now the identification, tracking, monitoring, metering, so this everything is available through internet. So this is the evolution, like sending the SMS and controlling the things or the monitoring the things from the remote control or from the remote location. It is the major evolution in the IoT. Now we will see the like how it got evaluated. So obviously it started with some small concept. When I say the IoT, it always starts with the hardware. Since we want to see some parameters of the device or some parameters of the thing around us, I need some kind of a hardware which can sense the parameter of that thing. So it started with the conceptualization, where actually I am proud to say that IoT concept started from the kitchen appliances. Like when we want to go outside the home, we definitely want to have our home in a safe condition, and we want to monitor or we want to visualize the home parameters. For example, fan is on or off, my AC is working or not, my fridge is working or not. So these are the small concepts where the IoT concept got initiated or got started or clicked to somebody that these things should be controlled or monitored from the remote location. So it is started with the concept, and as I said, IoT itself starts with the hardware. So we need some kind of a smart hardware. As I have already given you the example of smart bottle, basically the bottle was not smart, but then IoT made it smart. So we connected or we integrated some kind of a sensors to that bottle, now which can tell us like what is the water level of that bottle, how much is the pressure of that bottle, how much is the level of water in that bottle. So all these parameters which are telling the things or the some parameters about that bottle makes that bottle the smart. So we need smart hardware to integrate the IoT. The next thing, now we can sense everything from that bottle or any kind of a hardware. Now we have all the data with us. Now we want to process that data, since we want to achieve something out of that. So we need to process, or basically we want to collect that data, we want to send that data, or we want to store that data at some place. For that we need smart network. So this is the next layer or this is the next key component of the IoT. So likewise, if you can see, it has got after smart network, we definitely need some wireless network to send the data from one location to other location. Then we need to compute the data to get some kind of a result out of that data. Since we have gathered the data from all the data points all over the globe, we need to follow some kind of a standards, otherwise it will be a loss of data. The data will be open to all the world. It won't be secure data. So for that we need to follow some kind of a standardization all over the globe. Likewise, in the coming slides I will explain you what edge computing is, and these are the new trends like cyber security, then 5G and low power connectivity in IoT, and AI and AI/ML, which is like artificial intelligence and machine learning are the new trends in the IoT. So in the next slide we will be going through the key components of the IoT. So as you can see, these are the key components of the IoT. So IoT itself, it starts from the thing. As I already have explained you, things or object means any physical object around us, whether it is place, whether it is any kind of a thing, whether it is any kind of hardware, whether it is any kind of a machine in the plant or energy resource or anything which is around us. So that becomes things. When we say thing, now we want to monitor that thing or we want to get some data out of thing. That thing should tell us about its health. So we want to get the parameter out of that thing. We want to get some kind of a data out of that thing. So to get that data, we definitely need some kind of a hardware. We definitely need some kind of a sensors or actuators which we can integrate with that thing, and then we can read the data out of thing. So next key component is sensors or actuators which we want to integrate with that thing to get or to read the data out of that. The next part is connectivity. Obviously now we have integrated the hardware with that thing and we have some data. So to get that data, or now we have big data in our hand. So to get that data or to store that data at some place, we need some kind of a connectivity. For example, we have n number of sensors available in the market which are connected through Wi-Fi, connected through Bluetooth, Zigbee, RFID, some cellular network. So these are kind of a connections or the network protocols which are available with the hardware. So this is the next part or the next layer, like connectivity. Now we have we have all the sensors and actuators. Now we have collected the data. Now we want to process that data or we want to send that data at some place. So in data processing there are two types, like edge computing and the cloud computing. Third is fog computing, but for now we will see what is edge computing and what is cloud computing. Then these are communication protocol by which we can send the data which we already have stored, which we already have gathered from the thing or the object around us to the cloud. Then these are the communication protocols like MQTT, CoAP and HTTP. These are just some of the examples of the communication protocol. The thing is now we already have stored the data. There are n number of different types of industries, there are n number of different types of devices, there are different businesses altogether. So we definitely want to secure our data. For example, in banking sector, we definitely want to secure our data. There is not any mishaps or nobody can misuse our data. So data security is the most important thing in the IoT. Since it's a big data, there are huge number of data points around us. Everybody is generating data or everything is generating the data. So we want to secure our data. So the data security is the major part. So how can we secure our data? It's like we can definitely use the method of encryption. Then we can give authentication to use that data, and we can follow some kind of a standards. So this is the major key point of the IoT, the data security. The next is IoT platform. Now we have all the data, we have all different types of communication protocol, for example MQTT or HTTP. Then we have different data storage system or the database to store the data. Then so all these things, if somebody is making available all these things on a same platform, then it is called as a IoT platform. For example, we have different IoT platforms available, AWS or PTC ThingWorks or Home Assistant. There are any number of paid as well as open source platform available. We'll see some of the examples. Home Assistant, for example, in that case Home Assistant is the open source platform. So these are the IoT platforms available in the market. So moving to the next key component, we need to have user interface. We have data, we have analyzed the data, we have concluded something out of that data. So now we want to communicate that data to the world around us. So we need some kind of a user interface. In that case, we need mobile application or the web interface. So this is called as user interface. As I already have explained to you, we have to follow some kind of a standard to make our data secure or to make data available to the world. So that is the next key component. Since IoT always starts from the hardware, or it always starts with the sensors or kind of a gateway, so we need low power connectivity. It also has got the smart network as it's one of the key components. So it always starts with the low power connectivity. So we need power supply or the energy efficiency. So these are some of the few key components of the IoT. We already have seen what are the things around us, how we can make those things smarter by connecting the hardware. So what is the role of communication protocol, what are the networks, how data is getting stored, and how the applications are made out of that. These all are nothing but the layers of the IoT architecture. As you can see on the screen, just one block diagram or the diagram of the architecture. The lowest layer is the hardware layer, which has got the things around us. For example, anything around us, then the machines from the plant, any energy resources, earth moving equipment, or any robotics machine or any packaging machines, any kind of a machines, all these comes in the hardware layer. Now we are connecting some sensors to those machines to get the health of those machines or to get the parameters of those machines. When I say the parameters, it is, for example, you want to measure the temperature of the machine, environmental parameters of that plant, or vibration, pressure. You want to monitor any kind of a parameter, then you can connect the sensor to this hardware layer of the IoT architecture. Then now you are collecting the data of this hardware layer. Now you want to get the data from this layer to the data layer. Then you have to use the communication protocol, for example Wi-Fi, Bluetooth, then MQTT, OPC-UA. These are some of the communication protocol or the network protocol which connects your IoT devices to the data layer. The third layer is the data layer or the middle layer, where you collect your data, where you store your data, where you make your data secure, and where you massage your data. Massaging the data is nothing but it is a big field of data analysis, out of which you conclude something about that data. For example, if one of the machines is not doing well, then for example its temperature is beyond some range, then you are sensing that temperature, then you want to collect the readings of the temperature and you want to conclude that yes, this machine is going to die, or this machine will not be performing after 2 days if this is the trend of the temperature. So you want to basically collect the data or collect the readings of the temperature, you want to analyze that data and you want to prepare some trends out of that data and you want to conclude something about that. So for to conclude something, you need to store some data, or you need to have some data. So that massaging of the data and that storage of the data is been done in the middle layer. So now you have concluded the data, you have massaged the data. The next layer is the application layer, where you want to send your conclusions to the upper management or to some third party applications. For example, this application would be PLM, QMS or ERP systems or any kind of a dashboards or any kind of a reports which you want to present to your management team. So that is what is the highest level of the IoT, like the application layer or the application management layer. So this is how the layers of architecture for IoT. This is just one of the examples, like how different types of machine are connected on the same platform. For example, we have different type of hardware around us. Some type of hardware is available on RS-232 communication protocol. Some type of hardware is available on the Modbus. Some type of machine are talking to us on Ethernet. Some type of machine are available, machine or sensor or hardware is available on the Bluetooth or Wi-Fi. Then how everything is connected or everything is connected on the same platform. For example, this is the robot, it has got built-in sensor and this has got Ethernet port. These are the CNC machine and has got some serial port or Ethernet port. These are some of the non-computerized machine and they are attached with the sensor and on our different communication protocol. Then how will you handle different type of data or different type of communication protocols and bringing them on the same platform? Then here there is the concept of industrial gateway or the IoT gateway, which converts or which becomes the mediator between data of two different types of data rather. So you can convert data coming from RS-232 or RS-485 to Ethernet using the IoT gateway. Gateway is basically kind of a converter which converts one type of data to the other type of data. So due to using the industrial gateway or using the IoT gateway, you can connect all different type of machines on the one platform and you can get data out of it. So this is the brief description of the layers of architecture. We'll just touch base the OT and IT side of the IoT. As I said, IoT, it's a combination of OT and IT. So OT means the operation technology and IT means the information technology. In operation technology, it always starts with the hardware, with the sensor, with the objects, with the connectivity. It has got communication part, it has got network part. So basically, making the data or collecting the data is the part of OT, whereas massaging the data, getting some conclusions out of that data, dashboards, reports, then preparing data preparation. So this is then preparing the mobile application or desktop application or web portal or web application. So this all part is the IT content. So this is the combination of OT side and IT side. We need both type of knowledge to be an IoT expert. So I have just shown one block diagram which explains like how different things are making the data available for the IoT. So this is third party devices which are connected to the cloud through HTTP. This is directly connected devices to the cloud. This is one of the industrial gateway where you can say the sensors are connected, those are connected on the Modbus, but whereas we are using the IoT gateway which converts the data from Modbus to the HTTP. So now this data also is available on the HTTP. This is the SCADA application which is used for graphical user interface in the industry. So that also is available on the HTTP. This is OPC UA is one of the IoT gateway. By using OPC UA you can get the data of industrial controller to your expected network protocol. So this is the OPC UA. You have the machines which are connected through the or which are OPC UA enabled, and you can get the data from OPC UA enabled machines to the HTTP. These are the network service providers like cellular networks or the satellite networks. You can get again you can use the industrial gateway or the IoT gateway to get all the data available on the HTTP. So now you have different scenarios, different types of communication protocol, and you have now the every data is available on the HTTP on the same platform. So this is the OT side and the IT side of the IoT. So moving ahead, now we will see some details of IoT. In that we will cover different IoT platforms and data or the network protocols. We will cover IoT sensor or what type of hardware basically that comes in the IoT, how sensors are getting connected to the development board, then the difference, just the brief difference between the edge computing and the cloud computing, different database data analysis tools, data security, and details of MQTT and LoRaWAN, which are the prominent technologies, communication technologies in the IoT. So just to take few names from the IoT platforms and the network protocols, these are the platforms like Google Cloud, Practice, IBM, these are some of the cloud platforms. As I said, there are open source IoT cloud platforms also are available. Then as we already have seen, there are some data protocols, MQTT, CoAP, HTTP, Z-Wave, and the LoRaWAN. And as I have mentioned, open source platform, there are Eclipse, Thingsboard, Home Assistant, these are the open source platform where you can download those platforms, and you can, it's like a plug and play platform, so you can connect your sensors, you can get the data, and you can publish, or you can get your dashboards or reports out of that. These are some of the wireless IoT network protocols: Bluetooth, Zigbee, Wi-Fi, Thread Group, LoRaWAN. These are just to take the few names or to make you familiar with the names or the technology names in the IoT. So these are the things. These are some of the global suppliers or the manufacturers which are of IoT sensors and the hardware. So these are the industrial controllers. These are the key players: Honeywell, Schneider, Rockwell, Siemens. These are the manufacturers of the IoT industrial controllers. Then these are the IoT gateways. As I said, gateway is nothing but which converts one type of data to the other type of data. So RS-232 to Ethernet, then you can use RS-485 to Ethernet, RS-232 to USB, Bluetooth to CAN. And then these are some of the players which are manufacturer of sensors, like again IFM, Banner, Omron, Bosch. These are the players. These are the edge controls. I'll just explain it in the next slide. And these are the development boards which you use for IoT development, like ESP8266, ESP32, ESP01. These are some of the development board. When I talk about the sensors, these are the different sensors to get the parameters of the anything or any machine. Just to read the parameters like machine vision, flow, acceleration, chemical, electric, acoustic, leaks, humidity, force, load, temperature. So these are different types smart sensor out of which you can read the data of the machine. This is just one of the example how you can connect the sensor to the IoT development board. As I told you the name ESP01, whether it's a Wi-Fi board, ESP32 or ESP8266, you can connect. This is the sensor and this is the IoT gateway. This sensor is having RS-485 port. So the gateway is used where RS-485 to TTL converter, through which you can connect your sensor to this ESP board. So this ESP is enabled of MQTT. So you can send your data through to this ESP board to the any Raspberry Pi or any computer through MQTT. So this is just showing the connectivity of the hardware. So this is the main concept of the IoT, like I have explained, like edge computing and the cloud computing. We will see the difference of that. For example, you have the plant, you have n number of machine which are lying in the plant, and you have two types of data. One type of data which is of critical parameter, out of which you can get kind of an emergency signal. For example, you have catch some fire in the plant, and now you want to get some kind of a notification or alerts, or you want to you want to make the sound of the buzzer. So this is emergency type of data. And other type of data where you want to monitor some kind of a vibration, some kind of a pressure, some kind of a temperature, or some kind of a other things which are critical but not in the emergency situation. So there are two, so this data is segregated in two ways. One is emergency type of data, one is non-emergency type of data. So we have integrated the sensor to the machine and we are reading all the parameters out of those machines. Now we have segregated the data like emergency data and non-emergency data. Emergency data is sent to the local server so that it can be massaged or it can be analyzed very quickly and will give you the result very quickly. Whereas the data which is not that critical is sent to the remote cloud, remote server or the cloud, then it gets analyzed in the cloud and some kind of a report or some kind of a dashboard is produced out of that. Sometimes it is okay to okay for the management to get the report of the daily routine of that plant at the time of when the shift gets over. But in case of fire, management will not wait to get the data on the cloud, and it is getting computed on the cloud, it is getting analyzed in the cloud, and at the end of the shift or at the end of the day it will fire the alarm. So this is not expected. So that emergency alarm should be immediately communicated or immediately should happen. So the data which is critical is normally sent to the local server. Now you can see this is the physical layer which is generating the data. So the data now which is very critical is sent to the local server and it is getting analyzed, it is getting stored and it is being published at this layer only. And the data which is non-critical is normally sent to the cloud. It takes time for the data analysis and to communicate back to the machines or to the plant. It takes time, and which is okay since it is not non-emergent data. So the data which is being computed at the edge or at the local level is called as edge computing, whereas the data which is getting computed in the cloud is called as a cloud computing. You can see the next slide. Yeah. So these are the edge nodes. These are the machines, or this is the core network, and these are the edge devices where the emergency data is getting computed. So this is the edge computing, and the data which is computed in the cloud is called as a cloud computing. So this is the basic difference between the edge computing and the cloud computing. Now when we say the cloud computing, you can definitely use, for example, we have the Azure or the AWS are the paid cloud services. When we say cloud computing, it has got their own advantages. For example, you can use the data storage system or the database system of that cloud vendor. Then you can use their cyber security or data security. You can use their computing or data analysis tools as well. You can use data encryption or authentication, which are methods for the data security for that cloud services. And all these services are, I mean, this is the advantage of cloud computing, that you will get all the paid services from those vendors, whereas at edge level you might not be getting all these services at the edge level. So this is the difference between the edge computing and the cloud computing. As we say, MQTT and LoRaWAN are the major communication protocol in the IoT. So we'll just brief about the MQTT data flow. So as you can see, this is the architecture of the MQTT. There are three major components, or there are three major layers of the MQTT. One is publisher, next one is MQTT broker, and the third is subscriber. So publisher, as I explained you, the thing which is producing data, kind of a sensor, any gateway, or these are the things which produces the data, which has their own data to the things to which sensors are integrated. So these are the things which publishes the data. So this is something like, I have the data, now I want to publish this data. And subscriber, the things or the devices, for example your mobile, your server, your PC, or any of the third party application, these are the subscribers which want to get the data. So these are the publisher, these are the subscriber, and whereas MQTT broker is the mediator between the publisher and the subscriber. So publisher publishes the data. If subscriber has subscribed for that data through the MQTT broker, then and then only the data which publisher has published will send the data to that subscriber, or the subscriber will get that data only to which it has subscribed through MQTT broker. So this is the MQTT architecture. This is the simple MQTT architecture. In MQTT you will get local as well as global license. Local licensed is used, or the local setup is used to send the data on your local network, whereas global global license is used to send the data from the device to the cloud. So this is how the MQTT works. So this I already have explained. For example, Raspberry Pi with connected with the sensor, then that becomes your publisher, since it has data to publish or to give to some subscriber. Then MQTT broker is the mediator between the publisher and the subscriber, and this is your control center or the data center which has its own server or PC or any mobile application. So this becomes your subscriber. So these are the locations where you can install the MQTT broker. So whether it is local service or devices, or cloud platforms, or any IoT platforms. These are some of the examples of the open source MQTT broker, Mosquito and HiveMQ. So this is all about MQTT data communication protocol. Next is LoRaWAN technology. This it works on the radio frequency. So it also has got architecture. For example, it has got end devices which is called as node. Then it has got gateway, which is the mediator between the node or the hardware and the network server. Then network server, which collects the data from all the different LoRaWAN enabled devices, and then it gives that data to the application server. So it has got four different layers, LoRaWAN technology, and it works on the RF radio frequency. So end devices, gateways, network server and the application server. And so we will see the communication part of the LoRaWAN technology. So LoRaWAN uses unlicensed radio frequency bands. Typically it is in a gigahertz range. For it is 868 megahertz in Europe and 915 megahertz in North America. So this is radio frequency technology. So these two are basically very prominent communication protocol in the IoT, the MQTT and the LoRaWAN. Now you will think like, how can we decide the framework, or how can we decide what type of a network somebody should use to integrate the IoT. So these are some of the parameters by which we can decide for which kind of a framework we want to go. First is definitely the data security. The second one is range and coverage. For example, MQTT is for small area or for small range or small coverage of network, whereas LoRaWAN itself it's a long range wide area network. So it is normally used where we want to cover the large area. For example, if we think about the smart city project, then we have different things at different location and we want to connect everything on the same network. So it has, we definitely want to use LoRaWAN technology instead of MQTT technology. So this is the next parameter, like range and coverage, to decide the framework. Then the next is use case. Definitely, for example, as I already have explained in the previous slide, that we in the hardware layer we have different types of machines, we have different types of hardware or sensor which is available on different type of protocol. For example, something is getting connected on the Bluetooth, something is getting connected on the Wi-Fi, something is available on the RS232, something is getting on RS485. So we have different types of communication protocol. So the use case, you have to decide the framework according to the use case. What type of a communication protocol is available in that plant, whether those gateways are available in the market, whether you are able to convert one type of data to another type of data, what type of cloud service is available. So all these parameter decides the use case on which you want to work. The next is scalability. Project is, or how can we scale up this application, what we are looking out of this application in the future. So the scalability is also one of the major points, and the open standards basically. So whether we want to go for any kind of a paid platform or whether we want to use any open source platform. So these are the factors which definitely decide the framework, the communication protocol or the network protocol or the IoT platform you want to use for your IoT application. So these are some of the parameters. As the data is basically the you can say the major key component of the IoT, where you want to store the data, where you want to achieve the data security, where you want to massage the data, or you want to analyze the data to get some kind of a result or to get some kind of a reports out of that. So these are some of the names for that. For example, IoT database, these are like time series database, edge database, cloud based database, SQL or blockchain. When I say edge database, so the database which is available on the edge level, as I already have explained you, the edge level, which is the level of the computing which is available in the nearby location, for example the local server. So the database which is available on the local server or the local edge level is called as a edge database, whereas the cloud database, the cloud vendor which are offering the database, so it is called as a cloud based database. So these are the database. Then these are some of the data analytics tool. This is these all open source data analysis tool are Python with Panda and NumPy libraries. Then Excel, Power BI, obviously from the Microsoft Office. Then Grafana and Jupyter Notebooks. So these are the data analytics tool where you can enter your big data and then you can put prepare the graphs, dashboards, or you can even prepare the alerts, notification. You can send messages, you can send alert emails to out of that data. Then these are some of the machine learning tool. I will not deep dive into the machine learning tool since our session is of IoT, but these are some of the tools available in the market for the machine learning. We'll just go through a couple of industrial use cases for the IoT so that you can understand like how IoT is integrated in the industry. For that, this is the ecosystem. For example, this actually explains you the layers of architecture which we already have discussed. For example, the physical layer or the hardware layer, then the communication layer. The communication layer where we use the MQTT, co-op, these are the communication protocol. This is the middleware layer where your data is getting massaged, then you are doing some kind of analysis or you are computing your data, and the next is application layer. So this is what is the ecosystem is required to integrate any type of IoT use case in the industry. So this is just the ecosystem. So we'll see one of the use cases is energy management for the building facility, any commercial building facility. So what is energy management? So when we want to monitor and control the energy consumption of the building facility, for example, there are a number of rooms, out of 3 rooms are getting used and 2 rooms are not getting used, then I definitely want to switch off the lights, AC or any type of devices in that room. So this is what this is nothing but the controlling the loads or the electrical loads of that building facility. At some of the areas, for example, I want to monitor and control the temperature of the AC so that the electrical consumption will be minimal. So I want to prevent the leakage of the energy. I want to control, or I want to minimize the energy consumption. So this is nothing but the energy management system of that building facility. So how can we do that? So basically we want to define the problem, what we want to achieve under energy management system. So what exactly we are looking for? So we want to minimize the electricity bill. So for that we want to minimize the energy consumption of that building facility. So now we have defined the problem statement. So this is the first step, like define the problem, what you want to achieve. Even if you get the data, what you want to achieve out of that data. After analyzing data, what should be the result of that data, what that data should tell you, what problem it should describe you. So that is what is the defining of the problem. So we have defined the problem. For example, critical production area, this I have just written down some of the industrial terms like load distribution, production efficiency, or these are machine related terms, but these are applied for the energy management system. For example, cutting the cost down, minimizing the energy consumption, finding out the leakage of the energy sources. So this is nothing but the defining the problem. In the next step, now we have defined our problem. Now we want to measure those critical parameters so that we can read out of something that. So what are the energy measuring instruments? The energy meters or energy data points, or we can do the energy audits. We can use IOT devices to measure the energy. So these are the this comes under the energy measurement. The next part is monitoring. We have the data, we have collected all the data points, we have all the parameters, we already have integrated the smart hardware with our energy source system. So the next point is to monitor that parameters. So we have the system, we have data analysis tools through which, and we have displays. So we already have visualized the data, so we are monitoring that data. So that comes under the monitoring of the data. The next is, now we have monitored the data, now data is telling something out of it, that these are the points where the leakage is happening, or these are the areas where you can look into and you can lessen your energy consumptions. So these are the points where we want to improve. So some of the points we want to improve through some putting some notices, putting some displays, putting some signs around us, and some of the points we can improve through the automation or switching on off loads or integrating some kind of a sensor. So that comes under the improve category. Yeah, once we have improved the parameters, the next part is controlling. So it gives the advantages, like now we have reduced energy bills, we have quicker ROI, we have reduced carbon footprint. So these are the advantages. And just to show you the actual dashboard. So this is the dashboard which is coming out of the energy management for the facility, one of the commercial building. So what we have done, we have prepared the network, we have prepared the mesh of all smart energy meters. So we have connected the Wi-Fi board ESP, which is a ESP8266, to those energy meters. We are reading the data of all the energy meters. Now all the energy meters are talking to each other and they are sharing their loads. For example, some energy meters are dedicated for the lights, some energy meters are dedicated to HVAC system, some energy meters are dedicated to AC. Now they are talking to each other and they are talking in terms of technology, they are talking in terms of critical parameters, and they are sharing the load and they are managing the loads. So this is how IoT plays a very important role in the industrial revolution, and these are the advantages of the IoT. This makes our life smarter and better. Thank you.